Welcome. So I am going to go over rate of change with you guys. So let's start off with something pretty, hopefully pretty basic. So find the rate of change of the following between the years of 2001 and 2005. So we're looking at year 2001, how much it was, and 2005. So we know that between the years of 2001 and 2005, right? 2001 it was 290, while 2005 was also 290. So what is the difference between these two? Well, the difference is zero, right? 290 minus 290 is just zero. And the difference between these two would be just four, right? So in this case, our rate of change would be zero. There was no change in the average sales for between those years, even though we could actually figure out all of these, but we're looking at specifically those two numbers. Okay. Now, for the second problem, we have 1998. So it's this one right here, which is 206. And then we have 2003, which is 306. Okay. Now, most of the time, you always want to get your second numbers and subtract it from our first numbers. So I'm going to go 306 minus 206, which gives me 100. And then I'm going to take 2003 and I'm going to subtract 1998, which in this case would give us 5. So pardon me really quick. I should color code because I have things color coded and it's going to make a little bit more sense right now. So give me a second real quick to catch up. So now what we want to do with these numbers is we want to divide them. Okay. So we always take um, our y values and we divide it by our x values. So our rate of change will be always y over x. Okay, so you want to keep this in mind. Our rate of change is going to be y over x. Now, in this problem over here, excuse me, I kind of already did that in my head when I was kind of like solving it. But in essence, that's what I did. I did this process steps in my head when I was talking this problem up. So right here on this problem, we're going to have 100 divided by 5, which is 20. Sorry, I don't know why I wrote 200, but it's 20. Okay, so and in this case would be sales per year, right? They're talking about sales and per year. Now, sometimes it's really neat when to get the rate of change when they give you something like this, a list, a table, and they're literally telling you which two to look at, right? So it's really nice. Now, where it gets a little, I wouldn't say messy, but where it gets a little bit interesting is when they give you something like this, where they give you two x's and an equation. So what they really want you to do is they still want you to find the average rate of change. However, you have some steps you have to take before actually doing the rate of change or the slope. What you have to do is you actually have to find your y's. And how you do that is you take your x value and you actually plug it into the equation. So you're going to have -5 times -3 to the power of 3 plus 2. And you're going to do the same thing for both x's. Excuse me for me yawning. If you guys could hear me yawning, I am so sorry. Um, so right here we have -3 to the power of 3. So -3 times -3 times -3. So that would give us -27. -27 times a -5 will give us a, give me a second, let me get my calculator real quick, will give us a total of 135 plus 2, which would give us 137. Now, notice this is a power of 3. So when you're multiplying this, it's like -3 times -3. Oops. Times -3 times -3. So notice these two become a positive 9, but these two become a -27. That's why you were hearing me say -27 times -5. But -27 times -5 is just had my calculator open. I don't know why it shut off. Which is just 135. Then plus 2 is 137. So over here, we're going to get almost a similar answer, but we're going to have 3 times 3 times 3, which is 27, times a -5, which now will be a -35. And then -35 plus 2 would be -133. So now what I want to do is I want to label this one my x1 and this is my x2, which will now make this my y1 and this my y2. Okay, so now what I want to get is I want to get this number, -133. I want to subtract it from 137. Well, not from, subtract it with 137. And I want to do the kind of the same process with my x2 and my x1. So I'm going to get 3 minus a -3. So this is going to become a positive. So this right here, since there's two negatives, will become a positive. So we're going to have 6 right here. And then 133 and 137 would give us 270. So, well, sorry, -270. And then we reduce this. Let me choose a better color because that green is, can't really see it. So -270 divided by 6, which gives us -45. And that's our rate of change. Okay. Now over here on this problem, number 2, it's very similar. Okay. It's very similar. So when they give you this interval, they're telling you x1 is -3 and your x2 is your +2. And what they want is y1 and y2. So let's figure that out. So I'm going to plug in -3 wherever I see a x. Now here's where it gets a little not tricky because it's got the fraction, but it gets a little ugly, right? You're gonna be doing these powers, so I highly recommend you using that calculator app that I told you guys about, the Calc 84. It's really gonna come in handy right now. So you can literally write all of this in that calculator app all at once with parentheses, just like I wrote it right now, and it literally does all the work for you. And I get a grand total of 4,370 over 27. See, this is why I say it's very important to have this. Okay. Uh, and now what I'm going to do is now I'm going to do the exact same process, but now with a 2. Whoops. Instead of the -3. Okay, so I got to do these steps because I have to find out my y1 and my y2. Okay, so whoops. I'm typing it in right now, guys, so give me some time. There. And on this one, I get 65 over 2. So now I know what you're thinking. They're like, okay, we're done. Nope, we're not even done. Now we have to get our y2, which is this, and subtract it from my y1, which was this. Now remember, that's going to be all over my x2, which is this, minus my x1, which is this. So the bottom part is kind of easy, right? It's just 5. It's just top part that looks really, really scary, right? But it's okay. Just use the calculator I told you guys about, the Calc 84, and it makes things so much easier, okay? You can literally put the fractions the way you see it, and it's going to do all the work for you, okay? Now, you don't have to try to simplify anything. Just let the calculator do the work. And then you're going to come to this section right here. This response right here for the top. And then and then it's over 5. So then I take this and I divide by 5 and I get a grand total of negative 1397 over 54. And that is my rate of change. Okay. Now I know what you're thinking. Oh my God, this is so hard. You probably won't get homework problems that are going to be this I guess complex with all these fractions. You'll get more of these types over here, but I wanted to show you one that's just really crazy and that has big numbers, so you guys can kind of know that it doesn't matter whether you have nice numbers or crazy looking numbers. The rate of change is still the rate of change. You get your y2, you subtract it from your y1, and you divide it by your x2 minus your x1. So I'm going to write that over here. Okay, so it's a y2 minus y1 over x2 minus x1. So this is your rate of change formula. Rate of change formula. Okay, it's also known as the slope. And you should always have your y's on top and your x's on bottom. Okay. So now, like I always tell you guys, I always like to give you guys a little peek into calculus. I always like try to push the envelope a little bit. So this next part is going to be, we're going to do average rate of change, right? But we're going to do it in terms of a variable. So this is kind of like my x1, and this is kind of like my x2, right? This t. So what first thing I want to do is I want to find what is my y1 and what is my y2, okay? So, well, my y1, well, that one's it's going to be kind of easy. All I have to do is plug in 1 right here. And so I'll get 7 to the power of 1 squared minus 9, which is 7 minus 9, which is just negative 2. Now, I'm going to do the same concept for t, right? I plug it in for x. So then this becomes 7t squared minus 9. So this y2 is a little bit off. It's a little bit odd, right? So when we're doing our process of y2 minus y1 over x2 minus x1, it's going to look a little bit weird. But let's just run the course. We get our y2, which is 7t squared minus 9, and we're going to subtract our y1. So we're going to subtract our y1, and our y1 is a negative 2. Okay. Now our x2 was our t minus our x1, which in this case is just 1. Now I know what you guys are thinking. Oh, hey, sir, we could make this into a plus. That is correct. So we're going to have 7t squared minus 9 plus 2 all over t minus 1. And right here, we could combine like terms. Negative 9 plus t would give us that's a 7, by the way, 7t minus 7 over t minus 1. Okay. Hopefully that wasn't too painful. Now, our next step is to do something because I want to try to cancel this T1 on the bottom. Now, for this next step, we have to kind of see the math. So I noticed that they both, the top numbers, I could take out, factor out. Well, I chose the wrong color. Sorry. I could factor out a 7, leaving me t squared minus 1. Oh, wrong color again. So now I'm getting a little closer because I have my t1 and now I have a t squared minus 1. I want this to say t minus 1. Well, if you guys did not know, but this is a special trinomial, okay? A t squared minus 1 is called a difference of squares. Okay? So in actuality, I could expand this out to where it's t plus 1 and t minus 1. And I'm going to explain it right now off to the side right here. So, whoops. So t squared minus 1. I could factor this out, okay, to two factors, t plus 1 and t minus 1. This is kind of like saying this t squared minus 1. It's like saying t squared plus 0t minus 1. And then I would ask you, guys, can anybody think of two numbers that multiply to negative 1 but add up to 0? Now notice the zero's not here because it's 0. We don't need it. But I'm writing it here so you guys can kind of see what I'm trying to do here. Any number, what two numbers multiply to negative 1 but add up to 0? And yes, you are right. Positive 1 and negative 1. 1 times a negative 1 gives us a negative 1. 1 plus a negative 1 gives us a 0. So this is known as a difference of squares. Now, I say that because when you're able to see this somewhere, you always want to expand it out like that. And the reason being is because now I could cancel this t minus 1 and this t minus 1. And my average rate of change is just 7 times t plus 1. And that's kind of like a little peek into calculus. Hopefully it wasn't so bad. All right, let me move on. Now, this is like probably the part where I like to do the most. I feel like it's pretty fun. But then again, I'm a math teacher, right? So now you have to understand that there is a way to do this. Okay, so we read. Sorry, we read books, magazines from left to right, top to bottom. Okay, and we do the same thing with graphs. So if I was to start reading this graph right here, I would start roughly at this point, right? The top left. And if I was to say, if I'm traveling down this line, am I traveling up or down? Would I be traveling increasing or in decreasing motion if I'm traveling on this line? If I was traveling on this line, yeah, I would be decreasing. So notice that this is not an actual point. It's actually the little arrow. So the little arrow means it's on the left hand side going to infinity. So we would have negative infinity. And I'm putting it right here on decreasing because we said it's coming down. And it's going to go all decreasing all the way to this point. And this point is 1, 2, negative 2. So we would say from negative infinity to negative 2, we are decreasing. Now, if I was to continue my path on this line, and I'm going from this point to this point, do you think I'm increasing or decreasing here? That's right, guys. We are increasing. So from negative 2 to positive 1, we are increasing. Okay. And back on the line, if I'm still on this line and I'm following the line, would this be increasing or decreasing? That's right. It'd be decreasing. So I'm going to have 1, comma, and it's going to positive infinity. Now notice I use brackets here because these points were solid. These points were solid and they were colored in. Okay, they were shaded in. And that's how you find your increasing and decreasing intervals. Now, a couple of vocabulary words to kind of know is local maxima, local minima, global maxima, and global minima. What this means is pretty much on this graph, where do you see um, the minimum point would be, right? So let's kind of let me use this one. So this would be your minimum point, or one of them, right? And this point would be negative 2, comma 1, 2, 3, negative 3. Okay, and our global maximum point would be this one, right? That's the peak. I mean, sorry, our local maximum point would be this one, which is our peak, which would be 1, 1. Okay, so I think I was saying global. I meant to say local. So this is our local minimum point, and this is our local maximum point. So this is our highest point. And the reason why I try to emphasize the local and global is this. So local and global means this. Global means the entire graph, right? So if I was looking at this graph and all its points forever, what would be the global maximum? Well, the global maximum would probably be infinity because it's going to infinity, right? And the same thing for global minimum, right? The if I was looking at the entire graph, all the points, right? The global minimum will be infinity, in negative infinity, because it's going all the way down. However, we're not looking at the global right now. We're looking at the local because we're just looking at this little piece of this graph, and this little piece has a minimum point and it has a maximum point. And that's kind of like the difference between local maxima, global maxima, local minima, and global minima. Now, on your homework, you're not going to have to worry too much about global and this global maximum and global minima. You're just going to be worried about max and min, right? They're just going to say, what's the maximum point? What's the minimum point? And they're usually they're going to be talking about these 2 points. So don't overthink it. I'm just giving you all the vocabulary terms because it is necessary. All right. Now, let's work on this problem right here. Let's kind of do it all. Okay, right there. So again, we always start reading from left to right, top to bottom. Now there's no top here, so we're starting right here. So if I start right here and I'm coming up, well, I shouldn't say I'm coming up, but I already said it. So I'm coming up to this point right here. So I'm going in this direction. So I'm coming up. So that would be increasing. But remember, I started where the arrow is. The arrow is pointing down. So that's negative infinity to this point, which is -2. So I'm going to put parentheses and a bracket. Now, if I continue down this path, notice that I am coming down. So I'm coming down. So that means I'm decreasing. So from -2 all the way to 1, 2, 3, 4. So 4, +4. I'm decreasing. And notice when I'm doing the increasing and decreasing intervals, I'm only using the x values. I'm not using the y values. Okay. I'm using only these x values. Okay. Now, now notice if I continue on this path, now I'm going up. And so I would be going up from 4 all the way to positive infinity. Okay. So it's key to know this. All right. Now, what would be my maximum and my low minimum point? So we have one right here, and then we have one right here. Okay. So our maximum point would be this one right here, which would be -2 and -1. -2, -1. And that would be considered like a local maxima point. But we're just gonna call it maximum. And then our minimum point would be right here, which would be 4 and -4. Okay. Now, how do we determine domain range? Well, for the domain, we only look at the x values, right? So if we notice this graph is actually going to continue down and to the left forever, and it's going to continue up and to the right forever. So that means it's going to go all the way to -infinity and to positive infinity. Like it's going to go to the left forever, and it's going to go to the right forever. Now for the range, kind of a similar concept, but we're looking at the y's. And since this arrow is going down and to the left, it's also -infinity. And this is going up and to the right, so this is also positive infinity. Okay. So far, so good. So domain and range on a lot of these problems are they're going to be involving a lot of infinity symbols. So don't freak out, just stay the course. Now for this next part, I'm not going to do all these problems. I'm just going to do a couple of them because this was supposed to be kind of like I do one or two, model it, and then you guys were going to do some in class, like everybody was going to come up. But like I said, I'm absent, right? So I'd rather have you guys just see one or two good examples, and then you guys work on your practice problems at home. Now, I do see an error right here in the notes. This should have an X right here. Right here, that should have an X. So make sure you put that X, okay? All right. So here, as you guys can see, I'm asking you guys to make sure you have Desmos opened up, okay? So let me do a little split screen real quick. Give me a second. All right. So what I'm going to do is I'm going to type it in here. So I have 2x. I can't really get to the bottom of it. I wonder if okay. All right. So, uh, 2, man, can I move this? Okay. Oh, all right. There. 2x to the power of 3, and then we're going to have minus 13x squared plus 18x plus 10. All right, let me just make sure I have everything right. 2x 3 minus 13x squared plus, yep, everything is correct. So now this is why I like decimals, right? Decimals is really nice. It lets you graph very complicated problems, but this is the most, I guess, coolest, most interesting, most wonderful thing I love about decimals is that as soon as I click on the graph, some points pop up. You see, we have a point here, one here, 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 and here. And what it's doing is it's giving you the most important points of this graph. So, what would you guys think this is? What kind of point would this be? That is correct. That's the maximum point, right? This would be our maximum point that we were looking for. So we can write it right here, 0.865, comma, 17.138. And you see, and I love it because it gives you the answer. You don't really have to do too much, right? Now, look, now what do you think this one is? That's right. That would be our minimum point. So we would go right here and we would write in our minimum point, 3.468, negative 0.508. Now, I'm not going to really worry about the domain and range part right here, but I am going to worry about the increasing and decreasing. So notice, if I kind of zoom out from left to right, like, so there's nothing on the top. So I'm coming from the bottom and I'm going up to this point right here. So that means I'm increasing from negative infinity to this point of 0.865. Now remember, I'm only using the x values. Don't use the y values. Now, it decreases from the maximum point all the way to the minimum point. So by doing these max and mins, you actually solve one of the answers for yourself. So 0.865, comma 3.468. That, and oh, you know what? I'm putting parentheses, and that one should have been a bracket right here because it's shaded in. Okay. And notice, sorry, there it's decreasing from right here to right here. And then I'm gonna have another increasing from 3.468 to positive infinity. And here the domain and range would be from negative infinity to positive infinity because you can see that the graph is going up and down. So like one is going down all the way down and to the left, one is going up and to the right. So it's going to include both negative infinity and positive infinity. Now, we could do the same thing, right, for number 2. So let me you hide this one. And if I plug in number 2, 1 divided by 2, oops, forgot the arrow key, x to the power of 3 minus 12x squared minus 28x plus 1. Let me just make sure I have it right. Bap, bap, bap. Bap, bap, bap. Bap, bap, bap. And it looks good. And now I have this crazy looking graph. Well, oh my goodness, look at this. Oh my goodness. Oh my goodness. So I guess we already know what point this is. This is gonna be our what? You guessed it. It's gonna be our minimum point right there. So let's write that one in right now. Okay. So now let's go scroll up and we can get our maximum point right there, which would be negative 1.67, comma 18.229. Now, where is it increasing and decreasing? Well, this one's a little hard because we have to really zoom to see it, but we could actually see that it's coming from top to the bottom. So it's decreasing from negative infinity to our first point, which would be our minimum point, which would be negative 14.733. And then from negative 14.733, we already know that it's going to go increasing all the way to this point right here, which is our maximum point, negative 1.67. Whoops, brackets. And then from negative 1.6, it's going to start decreasing once again. So we're going to go, let me put it right here, negative 1.267, comma, to negative infinity. I'm sorry. Not negative infinity, positive infinity. Because we're doing x values, okay? And of course, the domain and range, it's going to be the same as before because it's going in both directions. So this would be positive infinity, positive infinity, negative infinity. Okay. Um, so hopefully that was pretty manageable, guys. Desmos is your friend for this homework. Okay, guys. It is rate of change and it's behavior graphs. The rate of change is just a slope formula. Behavior graphs is just finding max, min, and where it's increasing and decreasing. Okay. I'm going to give you guys the option of doing these two for a total of 4 bonus points. So 2 and 2, you get them done and you get your bonus points there. All right. See you guys later. Have a good one.